The circular sliding dovetail. I want to start off by first giving credit to Alex P.A., who invented this joint and is using it on a solid seat. My seat is 4 stretchers attached to 4 legs, and the joinery is the circular sliding dovetail. So it starts with the lathe and turning some stock into basically the socket to begin with, which is what this is. And very briefly on the lathe, I rough it out using the gouge tool, and then do some unique things to it to make this upper portion, which is the outer part of the socket, completely round and uniform, the inner part completely round and uniform. And then I have a taper on the bottom of my legs with a gradual curve going up to the socket, and that will be sculpted later on. But I have this taper down here, which is pretty much a perfect taper and perfect round cylinder, the large one and the small one, which is the inside of the socket. So I'm going to show you how I get that taper and perfect cylinders. I basically use a jig that I modified from the internet, so YouTube, etc. So what I do initially is I take off my tailstock and my chisel support, and I install this jig that I made, which is actually pretty cool. So it has a couple of parts to it. This top part, which you can change the angle or make it perfectly parallel, which gives me cylinder or taper. And then this bottom part, which has a clamp on it with bolts. These 2 bolts here are fixed and are used to secure the top part once I have the taper or the cylinder the way I want it. So this basically slides on and bolts down when I have it in position. Then this jig basically takes care of the chisel support. And then I put my tailstock back on. And then I'll take my leg and put it in. And secure it in here. And once that's in, I'll take this top part of the jig, put it in, and put the clamp down knobs on it. And then that basically leads to the second part of this jig, which is this really cool cutter head that I designed out of some scrap hard maple, a little bit of elevation of the cutter heads, and basically this is 2 cutter heads on a piece of scrap metal that I had laying around the shop that I bolted into the metal, and then bolted the metal into the solid maple. I've got a round cutter head, carbide. These are like around $10 to get a whole set of these things on the internet, and they last a really long time. And you could sharpen them on diamond if you wanted. Okay, so I've got this one for getting inside to the bottom of the socket, and I've got this for doing tapers and cylinders, this round one. So basically the way it works is it goes onto the platform, and then this is parallel. This edge here is parallel to the central axis of the workpiece. So once I get that parallel using tri-square, by making these two distances the same, I'll bring up the cutter and run it across. And that'll gradually take off the wood and will give me a perfect cylinder. And using the longer finger of it, I can then adjust this, make it perfectly parallel, and give myself a completely perfect and parallel surface of the inner socket. Now, once that's completed, I'll sand it down a little bit, and that pretty much gives me my rough leg. To get the taper, I basically run this a little bit askew of the central axis, and then just keep running the cutter across, and it'll eventually get it down to a perfect taper. Now this piece here is pretty unique because it has this bolt in it, which is a 1/4-20 thread, and it has 2 of them on this side to keep it parallel, and then this one is just for gradually bringing in the cutter head. And it's very accurate, 1/4-20, meaning each turn is 1/20th of an inch. So the other thing that's really good about this kind of a cutter head is that it keeps it at the exact same level, because as you go up and down, if you're doing this by hand across a chisel support, it changes the diameter and you get little squiggles in it. This makes a perfect round taper or cylinder, and then this will reach in. Once that's complete, I'll take it over to the router table, and very similar to how Alex PA does it, I'll put this back on a couple of pivot points and then rotate it directly over the center of the router bit in the router table and rotate it. And as I rotate it, I'll cut the inside. Now, once I've got that inside cut, I basically do it a little bit shy of the bottom of this socket, and that leaves a little ridge on the inside. So then I ground out a cutter head that has a little bit of a skew to it, and I could put this back on the lathe and take out that tiny little ridge that's in there, and that has given me a very uniform and flat and completely cylindrical inside and outside socket areas. The small radius has been cut. The large radius is now being cut by clamping the workpiece and moving out the bit towards the cut line. The bit is being moved with the crank in the back of the tail jig. It's being moved towards the left to the knife cut line where it just reached. Now that the large radius has been cut and the line has been sneaked up to by increasing the radius of the bit within the jig, the bit will now be moved down to the top red crayon and up to the bottom red crayon to cut the cheeks. This video is going to show an example of cutting the lower cheek from the bottom up.